Got something you want to share to the world? We got you, fam! We are looking for awesome people like you who want to share content that deserve a spotlight on our site. Whether it's a list of everything you love about catos and doggos, pop culture related artworks, or even your own random photos, memes, and funny videos, we'd be happy to see it and share it to the world. Join our award-winning team and be part of our Ink Pop creator community.
Hey, it's me, Guyito. Want to become a writer, artist, or photographer when you grow up? Test your creative skills with us. We're looking for kids aged 7 to 12 years old with unpublished work like articles, short stories, poems, essays, artworks, videos, and others. Join our award-winning team and be a part of our Kinderpop contributors and get your awesome work published for the entire world to see. Send in your work to pop@inquirer.net or visit facebook.com/inkpop to know more. Now let's show them how kids get it done.
1,392 ang nagkaso ng COVID-19 para sa 1,074
releases its COVID-19 update for July 12. Total cases here in the country are now at 56,259.
Please stand by as we are about to start the National Mechanical Engineering Students Convergence. This event is brought to you by Philippine Society of Mechanical Engineers, University of the Philippines Student Unit, Incorporated.
Our community partners:
JPSME Ateneo de Davao University, JPSME Central Mindanao University Chapter, JPSME Eastern Visayas State University Tacloban Chapter,
JPSME Polytechnic University of the Philippines Alfonso Campus, JPSME Polytechnic University of the Philippines Taguig Branch, JPSME Xavier University Chapter,
JPSME Mindanao State University Iligan Institute of Technology, Unified JPSME Northern Mindanao, Mechanical Engineering Society, University of Perpetual Help System Delta Calamba,
Mechanical Engineering Student Society Batangas State University, New Era University Association of Mechanical Engineering Students, PSME Southern Luzon State University, PSME Bicol State College of Applied Sciences and Technology Student Unit,
PSME Bicol University Student Unit, PSME Camarines Norte State College Student Unit, PSME Lyceum of the Philippines University Cavite Student Council,
PSME Manuel S. Enverga University Foundation Student Unit, PSME Mapua University Student Unit, PSME National University Student Unit, PSME University of Rizal System,
PSME Mariners Polytechnic Colleges Foundation Legazpi, PSME Technological Institute of the Philippines Manila Student Unit, PSME Technological Institute of the Philippines Quezon City Student Unit,
PSME Tarlac State University Student Unit, UP Society of Geodetic Engineers. Special thanks to UP Beta Epsilon Fraternity.
Our media partners, Inquirer.net, InkPop, SparkUp.
Some reminders for our audience. We have a charity drive entitled PSME Cares for Miss Dorothy Ann Cilio, who was diagnosed with acute lymphoblastic leukemia and passed away last August 20. John Roffer Equilios, on the other hand, lost his father and two siblings during a fire incident. A donation drive was initiated to help their families in these difficult times. Any amount would be a great help for their families to pay for hospital and funeral bills. Monetary donations may be sent to the following on your screen.
There will be a raffle winner picked every day of NMESC. To join the raffle, simply answer the evaluation forms to be sent out by the end of the day for a chance to win 200 pesos cash.
To those who wish to get their e-certificates, remember to answer the evaluation form at the end of the talk for your details.
If you have questions for the speaker, comment on the live stream with your full name /school/your question, and it will be carried over to the speaker by our moderators.
Disclaimer: the views and opinions of the guests and speakers do not necessarily represent those of the organizers and partners of this program.
On with the show.
Good evening, everyone, and welcome to the second day of this event. In celebration with the 14th PSME Month with the theme Link, Connect the Nation, Assemble the Future. We hold the National Mechanical Engineering Students Convergence. For years, the NMESC has brought mechanical engineering students the opportunity to learn from professionals and experts in the different fields of mechanical engineering. It has also presented students with the knowledge of an ME's life in the industry through company talks.
Yesterday, our speaker was Mr. Gabriel Lopez, who talked about innovation in mechanical engineering and actually engineering and business. And it was very useful. And a lot of people learned more about how they can innovate more about their products and with their plans, for example, in engineering especially.
But before we head on to our speaker, we'll be announcing the winner from yesterday's NMESC Daily Raffle promo. And the lucky winner of 200 peso cash is, are you guys ready? Noe Enrico C. Domanais, congratulations. You may now claim your prize by coordinating with the show's organizer. Again, congratulations, Mr. Noe.
Okay, moving on with the program. Our speaker for the day is a senior science research specialist at the prototyping division of the Department of Science and Technology's Metal Industry and Development Center. He is currently working with their Advanced Mechatronics Robotics and Industrial Automation Laboratory, or the AMIRIAL project. They contributed to the development of the Austria Vent 2, an affordable adult ventilator.
He had also obtained both his undergraduate and master's degree in the University of the Philippines, Diliman. He was also a DOSCRA 7687 scholar in his undergrad and a DOST ERDT scholar in his postgrad.
He also worked in the Metals Industry Research and Development Center, Materials and Process Research Division as a senior science research specialist. There, he designed and developed the semi-permanent coupler for the prototype train set. He currently has a patent pending for the hybrid electric train and an anti-climbing device with energy absorber from railway trains.
Again, for the audience, you may leave questions in the streams during the speaker's talk. Please include your full name and school before stating your question.
With that, we present to you Mr. Glen Espeña.
Hello. Okay, good evening, mechanical engineers, future mechanical engineers. So my name is Glen Espeña from the OST-MIRDC. So I will be discussing to you about the development of an adult ventilator, Straya Vent 2. So outline of my presentation. First is what is AMIRIAL project. So i-share sa inyo kung saan kami nanggaling. Then Straya Vent trademark or yung ventilator. Then paano yung development, ano yung story kung bakit nagkaroon ng Straya Vent 2. So first, the DOST together with MRSP, my program title na Transforming the Philippines MSMEs through Industry 4.0. One of the projects is the establishment of the Advanced Mechatronics, Robotics, and Industrial Automation Laboratory, or the AMIRIAL. So implementing agency, the OST-MIRDC, we have a partner, a private society, Mechatronics and Robotics Society of the Philippines, and headed by our Executive Director, Robert Odison. So the objectives of the project is to establish an industrial automation laboratory housed in DOST-MIRDC here in Bikutan and provide consultancy services for MSMEs and other organizations to conduct research and development activities, equipment design, and others. So, history sa Austria Vent. So, sa left na si Dr. Austria, he is the inventor of the Austria Vent infant ventilator, a locally developed ventilator na ginagamit ngayon sa Pilipinas sa mga infant na patients. So, this is from the website of austriavent.org. Parang doon nagsimula yung dinescribe pala dito kung saan nagsimula or paano na-conceptualize ni Dr. Austria yung ventilator at ano yung need niya talaga para magawa yun. So 15 years ago, nasa Tagbilaran daw siya. So may nakita siyang 12-year-old girl manually ventilating. So yun yung image sa katabi niya na example na manually pinapump yung bag para i-assist yung breathing ng infant. So, what if, tinanong niya, what if the child gets tired or fall asleep? So, anong mangyayari dun sa baby? So, yung sagot, sadly, then the baby dies, sir. So, mula doon, na-motivate si Dr. Austria para tulungan yung mga ganong cases dito sa Pilipinas, lalo-lalo na sa infant. So, nagtayo siya ng, may foundation sila, the Breath of Life Foundation Inc., a non-stock non-profit organization na nag-distribute ng mga Austria Vent to various hospitals in the Philippines. So, its mission is to provide a low-cost ventilator. Nakapatent siya sa Breath of Life Foundation for the support of the sick premature infants to increase their survival rate and reduce their immediate and long-term morbidities. So, recap lang sa, siguro alam niyo naman yung ventilator, sumikat siya, lalo na ngayong COVID pandemic. So, ang ventilator lang is to assist or help yung patient para makahinga siya. So maraming terms, respirator, breathing machine, or mechanical ventilation. So yung setup, parang yung usual na ventilator, itong nasa right side na image. May tinatawag naman na emergency use ventilators or EUVs. So sa time natin, kung nakapag kayo sa internet ng mga nakaraan, ito yung sa right side na image. Yung MIT, nag-develop sila ng EUV. So bakit EUV? So iba siya dun sa common or sa traditional na ventilator na maraming mga safety talaga, parang may certifications, dumaan sa maraming testing para i-cater yung madaming ranges ng need ng patient. So yung EUV, to produce them at rapid at i-deploy siya ng madaming mabilisan, merong pinatawag na EUV. So ito yung category ng mga ventilator na ginawa, inexpensive and often open source ventilators, kung saan ang target lang talagang tulungan nito ay yung mga COVID patients since nagkukulang nga sa supply ng ventilator sa mga hospitals. So, anong pinagkaiba ng Austria Vent sa usual na ventilator? So, dito sa illustration, makikita natin yung sa left side is a usual setup ng mga ventilator. So, yung patient, parang may tube siya galing din sa ventilator, tapos yung ventilator naman, may supply ng air. So yung ventilator na yung bahala mag-regulate ng flow at pressure ng air papunta doon sa patient. Then parang isi-simulate niya na rin yung inhale-exhale. So anong pinagkaiba ng Austria Vent? Unlike commercial ventilators wherein the device is placed between the supply of air and oxygen mixture and the patient, the Australia vent is placed under the patient after the patient, instead of directly controlling the gas mixture to the patient of the Australia vent exhaust air out of the system. Medyo magulo yan, so may illustration tayo. So dito sa typical ventilator configuration, makikita natin yung supply ng air and oxygen. So before kasi ma-inhale ng patient yung hangin, siniset ng mga doctors kung ano yung percentage ng oxygen. Pwedeng 100% oxygen or pwede namang 100% air or mixture. 50-50, 20-30, ay 21 yung pinakamababa na oxygen, so yun yung air. Maximum naman yung 100%. So sa typical na ventilator, yung patient, after ng supply, dadaan muna sa ventilator, then papunta sa patient. Tapos yung patient, mag-exhale, lalabas ulit dun sa ventilator. Ang pinagkaiba niya sa Australia vent, kung mapapansin nyo, nasa exhale side or exhaust side na ng patient nakakabit yung ventilator. May yung supply ng air, dediretso siya sa patient or humidifier, sa patient, then yung patient mag-exhale, yung hangin lalabas na doon sa exhaust. So dito nagko-control or nandito na sa exhaust side nagko-control yung ventilator. So to further illustrate yung system, yun is parang na-zoom in lang yung yung Australia vent. So parang during inhale, may mga valves dito. Ito manually operated na valve, ito naman solenoid valve. So during inhale, nakasara yung solenoid valve. Nakasara din yung itong tinatawag na PIP valve. Tapos may pressure sensor. So during inhale, pupunta lang yung hangin, pwedeng air or blend ng oxygen at air dito sa lung ng patient. Tapos yung ventilator na yung magko-control kung ilang seconds yung inhale time niya. Then after ng inhale, itong valve na solenoid, automatic magbubukas. So yung hangin, tutuloy-tuloy na siya sa PEP valve or yung sa exhale na side ng patient. So yung features ng Australia Vent 1, kung matatandaan nyo yung sa presentation ng Australia Vent 2 na. So ito yung 1, dito nagsimula talaga yung Australia Vent. So for infant siya. So pressure limit time cycle ventilator. Kung mapapansin niyo yung sa infant ventilators, ang common na type ay yung pressure limited. Hindi sinusukat yung volume, kundi yung pressure ng hangin dun sa lungs ng infant, yung kino-consider nila sa system. Then may 0 to 80 breaths per minute. Tapos ito yung pressure na ina-apply or pressure ng hangin na pumapasok or lumalabas sa lungs. So 0 to 15. PMH2O, unit din to ng pressure. 1 PSI is around 70 cmH2O. So mahina lang talaga yung pressure na experience ng paghinga natin. Then may mga alarms din siya and a bar graph display of the inhale and exhale pressure with alarm limits. Then may screen tas display ng waveforms ng pressure. Then may data log. So may limitations ang Australia Vent 1. Yun nga, for infant lang, tapos pressure control. Yung flow rate na kaya niyang i-accommodate is around 10 liters per minute lang. So for infant lang talaga. Then no tidal volume measurement. Itong tidal volume is yung volume na may-measure ng ventilator na ibinibigay or dinideliver sa lungs ng patient. So for adult, tidal volume measurement ang nire-require ng mga doctors. Then wala rin siyang bacterial or viral filter for COVID patients, so requirement to Then yung inspiratory time up to 8 seconds only. So, yung Straya Vent 2 ay parang na-develop or nag-start i-develop nung kasagsagan ng COVID-19 pandemic. So, in April 2020, yung Dean ng College of UP College of Medicine nag-reach out sa Breath of Life Foundation to explore modifying the infant ventilator to the use of adult patients. Since in-anticipate kanila na dadami yung mga COVID patients at darating ang point na ma-offset or mas dadami na sila kaysa sa number of ventilators ng hospitals sa Philippines. So yun, in-explore nila yung possibility na yun na pwedeng i-modify yung Straya Vent 2 at yun na, doon na nagsimula yung development ng ventilator for adult. So ito lang yung evolution niya from Straya Vent 1, yung white na ano, tapos yung Straya Vent 2 na prototype na ginawa ng UST together with Breath of Life Foundation. So yung main objective niya is to develop a ventilator not only for infant but also for adult use. And then may requirement na siya na dapat umabot ng 70 liters per minute yung air and oxygen mixture flow. Itong mga data na to is from our partners din sa research, yung mga doctors. So sila yung nagsasabi ng mga requirements. Tapos kami sa DOST, sinusunod lang namin or pinapacheck namin sa kanila kung okay na yung nagagawa. So sa mode naman, may pressure control, so for infant ngayon, tapos volume controls for adult. Then may dinadagdag yung pag-measure nga ng volume, then yung filter. So i-describe ko lang yung team ng R&D team ng para sa ventilator. So si Director Dizon, siya yung project head, siya rin yung nagko-coordinate sa mga doctors, kung anong requirement ng doctors, ano yung mga kailangang i-consider. So siya yung nakipag-coordinate doon. Together with Dr. Alex Paran. So professor siya, I think, dati from UP and Salazar. Then yung consultant siya, kasama siya ni Director Dizon sa pag-develop ng design ng ventilator. Then nahati yung team sa mechanical team tsaka sa electronics. So parang 3 versus 2. Sa electronics, sila yung sa control since may PLC at HMI tsaka mga sensors yung ventilator. So kumbaga, ito yung scope ng study tapos pinag-iwalay siya. So una, may before i-fabricate or mag-design ng setup ng system. So may numerical simulation muna yung kung paano ba nag-work yung ventilator. So nag-perform yung consultant, si Dr. Paran, ng numerical simulation ng ventilator through Scilab. Then yung data nun, yun na yung pinasok namin para sa design considerations ng ventilator, Straya Vent 2. So sa mechanical, ito yung kumbaga naging trabaho namin. So design of prototype, 3D CAD. So of course, ano muna, i-fit yung mga 3D models before mag-fabricate. So mga dimensions, so kinukuha na sila lahat. Nasama na doon. Then since pandemic, lockdown, sarado yung mga hardware, mahirap maghanap ng mga components. Buti na lang may mga 3D printers. So kami dun sa team nag-fabricate na lang or nag-print na lang kami ng mga fittings, manifolds para i-assemble yung ventilator. Then sa testing naman kami, nag-set up kami ng test lang simulator. Mamaya papakita ko yung setup para i-simulate yung paghinga ng tao or yung lung ng tao. Then sa electronic side naman, so yun nga, sila yung in charge sa design of control system ng ventilator. Since yung ventilator may mga sensors, So in-integrate siya sa PLC and HMI para yung mga alarm limits niya, yung kung paano magsasara or magbubukas yung valves, controlled ng PLC. Then sa testing naman, yung mga data, debugging, tsaka yung analysis results. So ito, sa ME side, i-share ko yung mga ginawa namin. So yung team namin, bago namin buuin yung prototype, so dumaan siya sa CAD model. Ito yung mga actual na knowing namin yung iba, actual na dimensions para makita namin yung pag-fit ng mga components sa loob ng case. So ito yung block dyan na parang manifold, tsaka yung mga fittings, tubes, 3D printed siya. Tapos itong case, aluminum na bended. Then ito, off-the-shelf, solenoid valves, PLC, fans, tapos yung HMI. So sa 3D printing, from CAD model to 3D printed objects na, ito na yung, ito tumagal ng parang 12 hours na printing. Ito naman, parang fitting siya na ginawa sa CAD, tapos then na-print ng 3D print. So ito yung mga samples ng mga, kumbaga, special purpose na fittings since wala kaming mabili na standard parts. So nag-3D print na lang kami from measuring ng mga idudugtong na components. So ito, nag-come up kami sa ito ay fittings para idugtong yung flow sensor sa tubes ng ventilator. Ito naman sa supply ng air. Sa air source papunta dun sa ventilator. Tapos ito yung para sa pressure sensor. So ito yung naging test setup namin dito sa laboratory. So kung makikita nyo, yung air source namin ay compressor lang siya. So sa hospital, di ba, may oxygen tapos supply ng air sa mga walls naka-attach. Kami, naghanap lang kami ng pwedeng mag-simulate yun. So air compressor. Tapos yung test lang naman, kung makikita nyo dito sa lower right na corner, inflatable bag, anesthesia bag siya na nilubog namin sa tank na may tubig. So doon niya masisimulate yung parang, since may tubig siya tapos nakalubog siya, yung hydrostatic pressure, siya yung parang magiging lung resistance. Yun yung magsisimulate ng paghinga ng tao. So then kinabit namin yung ventilator. So yung data namin na nakukuha based dito sa test lang model. Then, after mag-perfect yung mga measurements, sa pressure, gumamit kami ng handheld manometer lang. So, may mga points kami dyan na pinagsusukatan ng pressure hanggang sa makalibrate namin yung ventilator. Sa sa volume naman, minimeasure namin yung pagtaas at pagbaba ng tubig dito sa tank. So, yun yung ina-assume namin na naging volume ng air na pumasok dun sa lungs natin. Pumasok at lumabas. So sa ngayon, undergoing pa ng test for FDA certification yung ventilator. Hindi kasi basta-basta rin gagawa tapos iti-test na agad or gagamitin ng patient. So medyo stricto sila para din naman sa safety ng gagamit ng ventilator. Once na na-approve ng FDA yon, mag-resume na siya dun sa tinatawag na clinical trials. So yung mga doctors from PGH, ito turn over na namin yung ventilator. Tapos sila na yung magte-test at kukuha ng data dun sa mga actual na magiging patients nila. So yung naging output namin is the prototype of the ventilator for adults. Meron din kaming paper, scientific papers. Then yung fabrication drawing ng Australia to commercial models. Ang magiging goal kasi nito, once na na-approve na or naging maayos na yung clinical testing, dapat ready na siya for mass production. So, yung drawing, ibibigay na lang to dun sa Breath of Life Foundation, tapos sila na yung bahalang mag-mass produce. So, ito na lang yung mula din sa experience ni Dr. Austria na parang may time na nakakita siya ng 4 intubated premature infants connected through a common tubing and ventilated with one inflatable bag by one person. So, dun sa simula, nakita niya isa lang na infant, isa yung person nagpapump. Dito, mas malala. So, 4 na patients, tapos may isang tao na nagpapump ng bag. So, alam natin na once na tumigil yung isang tao na yon, napagod yung nagpapump, pwedeng mamatay yung 4 na patient. So, naisip niya na dapat tumigil na yung ganong, or matigil na yung ganong practice. Since ang ventilator naman is, sabi niya, not a complicated machine, and kaya naman natin gawin locally. Nagkakaroon lang ng parang kaya konti yung number of ventilators dito sa Pilipinas or sa hospitals kasi nga mahal yung mga commercial ventilators. So dahil doon, nakipag-tie up siya sa mga from engineers and professors sa UP at sa USD para i-develop na yung ventilator na Australian. So yun lang. Thank you.
Thank you so much, Glen Espeña. On to the question and answer. For the audience, if you have any questions, simply comment on the live stream your full name /school /your question.
For our first question, Roland from UPD asks, what were some of the problems you faced when designing the ventilator?
Una, since yun nga, iba lockdown, wala talaga kami pasok noon. Tapos yung boss ko, pinatawag lang kami sa office. Sinundo pa kami ng mga official vehicle ng UST. Kasi nga may project yung Breath of Life na gusto nilang ipagawa na adult ventilator yung infant. So, mula pa lang doon, since gagawa ng prototype, parang ang naisip namin, saan kami kukuha ng mga materials na gagawin? Since lockdown, sarado yung mga tindahan, hindi basta-basta makakalabas para maghanap ng mga components. Yun yung, kumbaga, naging challenge sa amin. So, buti na lang, may mga yung 3D printers, may mga machine din kasi dito sa MIRDC na pwedeng i-fabricate yung mga components. So, dahil doon, nasolusyonan naman yung problem. Pero yun talaga yung naging challenge, yung parang gumawa kami ng project na yun during lockdown.
Another question from Jeff Dison from PIF. Sir, magkano yung difference ng Austrovent 1 at 2? Tingin nyo kaya pa bang pababain yung price kung magde-design kayo ulit? Kung sakali, anong mga piyesa nito?
Kung mapapansin nyo, sa kasi yung iba yung R&D cost dun sa, kumbaga, commercial na yung i-produce or mass production. Sa R&D, yung prototype kasi na nagawa namin, medyo mahal siya kasi yun nga. Yung mga components, ginawa pa talaga namin specialized lang para dun sa setup na yun since wala kaming mabiling off-the-shelf na mga components. Pero siguro kung may mga makukuha na tayong off-the-shelf, mga fittings, hoses, mga valves na off-the-shelf tapos pwede mong mabili ng maramihan, mas malaki yung difference na ibababa pa ng presyo niya. Tapos compared sa mga ventilators na imported, sobrang layo talaga ng difference. Yun, nasagot ko ba yan?
Here another question from Nick Drake. What project do you want to or see yourself working on next?
Dito kasi sa amin sa Amerial, kumbaga kung ano yung need ng industry or ano yung MSMEs, yun kasi yung goal, isang goal ng project, parang ma-improve yung production ng mga MSMEs natin. So kahit anong project yun, maging simple lang, maglagay ka ng sensor o timers, basta makakatulong sa kanila. Yun yung ginagawa namin dito sa Amerial.
Another question from Nikki D from Santa Ana. Hi. Sir, ano nga ba yung components ng mga ventilator at parang ang mahal pa rin ng marami? Ano ba ang nagpapamahal sa ventilator?
Yung ventilator na sinasabi nila, yung imported kasi wala talagang locally fabricated pa. Or bukod dun sa Austria Vent 1, yung for infant, lahat ng ventilators na ginagamit sa mga hospitals dito sa Philippines ay imported. So yung cost pa lang ng pag-import nun, malaking percentage na yun na nagpapalaki dun sa price niya. At isa pa yung dito naman sa Austria Vent, since ang mga components ng mga ventilators, yung common na ginagamit ay parang dapat medical grade siya. Kasi parang ang air, dadaan muna sa ventilator bago pumasok sa lung ng patient. Sa Austria Vent kasi, nasa exhaust side na yung ventilator. So hindi necessarily lahat ng components niya ay medical grade. Kasi nga, yung flow, hindi naman babalik na papunta dun sa exhaust na siya. So yun yung nagpapamahal at nagpapamura din naman dun sa Austria Vent.
A question from McCoy D from CHS. Meron bang mga problema sa CAD design na paulit-ulit nyo kinakailangang balikan?
Madami. Kasi sa una pa lang yung pag-fit nung mga components sa loob. Kasi kung makikita mo yung ventilator, dapat kumbaga yung naka-expose na parts sa kanya dapat minimal lang. Kasi once na may mga parts dyan na exposed sa environment, pwedeng masira yon or mag-malfunction tapos magiging cause ng harm sa patient. So ang instruction sa amin ng mga doctors ay parang dapat yung design compact, pero at the same time, pag i-maintain mo siya, accessible yung mga parts. Kasi siyempre, 24/7 siyang ginagamit, so may mga mag-wear down talaga na parts doon or mag-lose na connection. Kailangan siyang i-maintain. So yun yung challenge. Paano gagawin na maging compact pero accessible pa rin? So yun yung nag-brainstorming kami lang kung paano bubuksan, kung saan i-mount yung ganitong component na yung pala laging binubuksan. Kung ilalagay natin siya dun sa pinakasulok, yung pala hindi naman siya kayang abutin na ng mag-maintain or kailangang baklasin lahat. So hindi siya applicable dun sa So yun yung naging challenge sa amin. At nag-come up naman kami ng tingin namin pinaka-compact at pinaka-madaling i-access yung mga components sa loob.
A question raised by Alinor B. Casan from UJP-SME MSU main campus. How does an engineering student get hired in the medical device industry?
Hindi ko alam eh. Actually kasi kami, sa DOST ako eh. So, hindi naman talaga kami nasa medical device industry. So, siguro kung may mga requirement na ganun for medical device industry, so malamang yung knowledge mo sa design as ME. Kasi yun talaga yung yung hinahanap sa atin. So, yung ng mga hardware. Yun siguro. Pero sa amin kasi sa DOST, kumbaga, kahit anong problem or R&D activity, tinatanggap naman namin. Kasi marami naman kaming mga tao dito na kayang gawin yung mga ganun problems.
Another question from Mikoy Torres from MHS. Do you have engineering projects you work on your personal time? If not, Is there something that you want to work on?
Madami kasi kaming trabaho so para kumbaga kahit personal time, minsan nakatuon pa din yung iniisip para dun sa mga projects na nasa trabaho sa DOST. So, yun, kung wala talaga, parang nag-aaral lang kami para i-anticipate yung mga next na magiging problems ng industry.
Another question from Janalo from UPD. Can you tell us about one of your favorite work experiences with Ameria?
Of course, yung sa Ventilator kasi yun nga, nag-start kami from the scratch talaga, tapos lockdown, tapos yung kumbaga kung gaano ka-importante yung ginagawa namin. So doon ko na feel yung ganito pala magtrabaho sa government. Since madami yung resources kasi ng government. So yun lang, kailangan nating i-maximize yun. So yun yung sa work ko, yun yung isa sa pinakamagandang experience.
Another question from Paul from UPD. He asks, what are some of the necessary skills needed when working with robotics?
Robotics? Actually, di ba, parang ngayon, hindi na lang, kumbaga yung industry, hindi na nila kailangan ng purely mechanical ka lang. Parang, kumbaga, may alam ka na rin sa mga programming, parang mag-merge niya yung discipline ng engineering. From mechanical, electrical, ECE, yung control. So, para makapag-gawa ka ng robotics na, kung ano mang project yun yung necessary na mga skills na kailangan talaga. Hindi lang sa ME na parang thermodynamics, mga stress, pati yung controls, tsaka yung electrical, yung kung paano ipapower yun. Kasama yun sa
Alex Turner asks, kung masyadong maraming trabaho sa work, sa engineer, paano ka nagsiset ng boundaries sa work and life?
Sa akin kasi, parang kung interested talaga ako dun sa project or sa work na ginagawa namin, parang work and life, parang na yun magkasama na. So, nandun yung passion mo sa ME nga, yung kung alam mo yung direction, bakit mo ginagawa yan, parang hindi mo ma-differentiate yung work and life na. Kasi yun naman talaga yung gusto mo. So, yun na yung work mo, yun pa yung life mo. Parang ganun.
Another question from Mikoy Torres from MHS. What advice would you give to people without any background on robotics or electronics related stuff to those who want to try and learn? And where should we start?
Ngayon, madami ng, di ba parang marami ng reference, pwede mong maging reference sa robotics or electronics, may internet, mga libro. Parang lang naman kasi kami, kaya ako, ME ako, pero nataon lang na may mga projects kami na electronics, robotics. So, kailangan gawin So, kailangan din aralin. Pag may problema, kumbaga, nandyan yung mga resources So, pwede mo, parang anytime, pwede kang mag-start, tapos maraming pwedeng pagkuhanan ng internet, mga journals, madami. Tsaka, syempre yung mga marunong din. Kasi kami, may mga kasama rin kami dito na, sa electronics, easy talaga sila. So, sinishare din naman talaga nila yung mga knowledge nila para maintindihan ng buong project.
Christian from NU asks, would you think mass production of fully built ventilators through 3D printing is possible?
Sa ngayon, yung technology kasi nung, di ba, yung 3D printing, kumbaga, nag-start parang mag-boom. So, may kamahalan pa siya. Kaya nga yung, di ba, ginagamit yung 3D printing for rapid prototyping. Mabilis siya gawin, pero may kamahalan. So, for mass production, sa ngayon, hindi pa natin mako-consider na efficient siya doon sa kasi nga, medyo may katagalan, at medyo may kamahalan kasi. Pero siguro may dating na technology na kaya nilang pababain yung presyo tsaka yung mga materials din. Ngayon, pwede na mag-print ng metal. So, siguro darating yung time na pwede na talaga gumawa ng metal.
A question from Rick John Pablo from PSME-UPSU. Kung matatapos niyo po yung project na ventilation, paano po ito makakatulong sa mahirap na mamamayan na naapektuhan ng COVID na gusto rin pong makasurvive?
Of course, dun sa yung magiging cost pa lang ng ventilator para mag-acquire yung isang hospital siguro. Para lang magkaroon ng, kasi ngayon, millions yung cost ng isang ventilator. So yung isang hospital, kung gusto nilang mag-acquire ng 10 ventilators, so kailangan nila at least 10 to 15 million para makapag-accommodate ng 10 na patient. Mahirap man yan or mayaman. Basta mag-isakit pare-pareho yan. So kung mapapababa natin yung cost ng yung locally developed na, malaki yung maitutulong nun sa mga pasyente. Kasi magkakaroon sila ng access sa ventilator.
Another question raised by Joseph from UP Diliman. Which lessons or topics that you learned in your undergrad studies would you say are most valuable and applicable in your current career projects?
PE. Hindi joke. Actually, di ko pa nagagamit yung Math 55 saka Math 54. Siguro yung thermodynamics, tapos mga engineering sciences. Yes. Yun yung nagamit.
Another question from Jeric Arvin H. Virtusio from MESS Batangas State University. Bakit niyo po napili na maging ME sa field of medicine?
I-clear ko lang, yung field of medicine, kumbaga, hindi talaga kami sa work ko. Since may R&D lang na from field of medicine, kaya kami napunta dun sa medicine na field sa paggawa ng ventilator. So kami kasi talaga industry, yung mga production ng MSMEs, yun yung tinututukan namin sa project. Nagkataon lang na yun nga, yung ventilator may ganung project. So hindi ko talaga pinili yun. Parang dumating lang yung project tapos ginawa namin. Ginawa namin na gamit yung natutunan ko sa ME na nakatulong naman.
John Michael from PSME DIP Manila. Mayroon po bang safety feature ang Austria Vent 2 in case na magkaroon ng error?
Yun. Isa yun sa mga requirement ng doctors. Yung mga alarms, kung tumaas yung pressure, may mechanical relief valve doon, tapos yung solenoid valve. Once na-detect niya yung mataas na pressure, halimbawa, shut off siya, parang i-release niya yung hangin para hindi mag-build up yung pressure sa lungs ng tao. Tapos kung mababa naman, since wala na parang supply, so mag-alarm siya na parang madidetect niya na mababa na yung pressure or yung flow ng air papunta sa patient. So may inform yung gagamit ng mga requirement talaga yun sa ventilator, yung mga ganong alarms.
A question from Roddy Gobert from UPD. Sir, para sa mga di taga-UP, Ano yung mga lessons sa subjects na binanggit mo kanina? Yung mga Math 54, 55 years.
Ano lang, joke lang naman yung yung, di ba yung, before, differential equations? So, yun, di talaga, siguro yung simulation na sa CAD, ginagamit nila yan, yung differential equations na yan. Nandun na yung built-in na yun eh. Pero dun sa ventilator namin, yung, siguro yung ano na lang, yung sa gas dynamics, thermodynamics, pressure, volume relation ng air, yung mga flow sa orifice, sa tubes, mga pressure drop, yun yung naging namin, kinailangang aralin ulit. Actually, nag-review pa rin naman kami para dun sa paggawa ng ventilator. And of course, yung mga stress. Siyempre, yung mga, nung nag-3D print na kami, kinoconsider din namin yung materials. So, saan yung may stress, may moving parts pa dyan, so kailangan supportahan or malakas yung load na kinikerry niya. So, kinoconsider namin yan. So, sa mga stress, kasama yun dun sa MA pa naman yun.
Lorraine Estosane from JPSME TUP Taguig. If ever ma-approve ng FDA DOH, may chance ba na mag-export tayo ng ventilator na ginawa nila?
Siguro. Siguro may kumbaga, di ba sa export naman, ano pa rin yun eh. Economic pa rin. So kung mas mura ka, same function, pwede mong yung may market ka sa iba. Pero kung hindi mo matapatan sa presyo yung mga nagmamass produce na, mahirap makahanap ng market sa abroad. So siguro kasi dadaan pa naman, madami pang R&D yung ventilator eh. Ngayon, prototype pa lang, kumbaga, kinonsider lang doon. Functionality, safety, tapos availability ng mga components niya. Kasi yun nga, yung kanina nabanggit ko yung emergency use ventilator. So, may need kasi, kaya nagganyan. Yung iba nga, parang bug lang na automatic na pinapump. Naging ventilator na yan eh. Kung tutusin, murang-mura talaga siya. So, kaso, kung mag-explore ka na ng export, dapat ba parang yung sa safety noon, sa quality, at of course sa presyo, dapat matapatan natin yung ibang brands na multinational na talaga na gumagawa ng ventilator.
A question from Mikoy Torres from MHS. Sir, meron ka bang moment na hindi mo naaalala yung isang concept or subject na kailangan nyo sa work at bigla kayong napa-review? Sir, kwento ko daw po kayo, sir. Kamusta daw yun?
Madami. Kasi usually sa work naman, hindi talaga, nandiyan lang, addition, subtraction, multiplication, yung usual eh. Siguro mag-solve ka ng mga equations, hindi, sa trabaho namin sa experience na. Kasi sa design naman sa amin, actual na kung anong available, tapos kung anong kailangan. Hindi mo na kailangan mag-compute ulit eh. May mga readily available na products na hindi mo na kailangan na diameter niya. Kasi yan na talaga eh. Kumbaga, ang gagawin mo na lang pagdudugtong-dugtungan. Pero of course, paminsan-minsan, yun nga, hanap ka rin na kailangan mag-review. So, yun lang, mga libro, may mga e-books naman, tapos journals, may access naman kami sa mga research projects na dati. Tapos of course, yung mga kasama din sa trabaho na nag-share din kami lagi ng pati yung boss ko, hands-on talaga yun sa sila pa mismo yung natuturo sa amin para dun sa project. Kumbaga, yung sharing naman ng knowledge, yun yung pinaka-best talaga na.
Dieter V. Kabahog from MSU IIT asks, is the said ventilator have assist control feature?
Sa ngayon, yung prototype, yung 7.2, wala pa siya. Yung may next kami, yun na yung tinatarget yung may assist control na feature. So baka yun na yung Australia Blend 3.
Another question from Armand from TIP Manila asks, what are your thoughts on the future of 3D printing in your field, especially in Amerial?
I-share ko lang, yung DOST MIRDC, may hiwalay siyang yung tinatawag naming Advanced Manufacturing Center kung saan focus talaga sila dun sa 3D printing technologies. So may sarili silang building ngayon na ginagawa, tapos nag-acquire sila ng iba't ibang 3D printers mula sa plastic 3D printers, ceramic, metals, tapos iba-ibang sizes kayang gawin. So malamang kasi yun naman talaga yung nagiging trend na sa prototyping, pati sa manufacturing. So in the future, na talaga, kakailangan natin yun. So yung DOST, meron na din kumbaga nag-prepare na talaga sila para i-serve yung Filipino sa industry, academe, para gamitin yung ganong technology.
Peter Joseph Atienza from Batangas State University. Questions lang po about Austria Vent 2. You said po that this ventilator is now undergoing tests for FDA certification before it is used in clinical trials. Kahit po ba undergoing test po ay meron na po ba kayong ginamitan ng Austria Vent 2 for trials like sa ibang hospital po?
Wala. Kasi hindi basta-basta kumbaga gagamitin sa patient yung ventilator kung hindi pa siya approved ng mga certification bodies. So yun, yung isa yung FDA doon na alam, naman ng hospital siya tsaka ng doctors na hindi pwedeng gamitin yung ventilator hanggat hindi siya pumapasa dun sa requirement ng FDA. Kaya ngayon, yun nga, hindi pwedeng pagsabay na nagte-test kami tapos nagpapa-approve. So ngayon, testing talaga, testing sa certification, saka siya ite-test sa tao.
Another question from Jamaica from URSSU. Did you conduct oxygen or O2 efficiency testing? Your design is only at the exhalation side. When the valve opens, the patient will exhale and nothing stops the pressure going out the blender.
Ayun, yun nga, yung sa concept niya, di ba yung may blender, so yun yung O2 doon na may measure. Tapos, yung design talaga ay yung system, yung Australia Vento, design siya na pag nag-exhale yung patient, wala nang dadaan na air dun sa lungs. Diretso siya sa ventilator, mag-exhaust na siya. So makikita medyo magastos to sa oxygen. Kasi during exhale, tuloy-tuloy pa rin yung pagbuga niya ng supply air para mag-exhale yung tao. Mag-inhale lang, yun nga, pag nakasara yung dalawang valves. So yun yung design kasi para ma-accommodate yung sa exhaust side ng patient i-install yung ventilator.
Raby Joy from NMESC asks, may mga projects po ba kayong nag-fail? Kung meron, how do you deal with it?
Ano kaya yung category? Paano nasabing nag-fail? Since yung R&D naman, parang wala namang sure kasi talaga na malaki lang yung chance na dapat since nag-project ka, kumbaga dapat 80% na ma-predict mo na yung magiging outcome. Pero may mga chances talaga na di mo maiiwasan after nung R&D, mako-consider mo na failed yung Pero hindi naman lang doon mismo sa output yan. Siyempre may mga learnings ka rin naman na natutunan doon sa process. So, pwedeng nag-fail yung mismong objective mo talaga. Pero yung knowledge, experience na nakuha ng mga researchers, kumbaga hindi pa naman siya failure talaga.
Another question from John Ray Fabricante from Central Mindanao University. He asks, how significant is the communication between medical experts and engineers, especially working on this type of project? How do you deal with communication barriers?
Ayun. So, ano lang, tanong lang ng tanong. Parang, kung may tanong ka sa kanila or sila may tanong sa'yo, parang, huwag mahiyang magtanong. Parang gano'n. Kasi, delikado pag nag-assume ka lang na ito yung iniisip niya, tapos, ikaw ito naman, baka may mangyari na magkaiba pala kayo ng iniisip, tapos once na in-execute nyo na yung decision na yun, magkakaroon ng problem. So yun, constant communication. Naintindihan naman yung mga English nila minsan eh. So, kaya namang intindihin ng engineer pag tinatanong mo ng mga examples. Ganun din naman kami, pag naipag-usap kami sa kanila, may mga graphs, yun na sa data, tapos i-simplify mo using examples na real life, nagkakaintindihan naman.
Another question from Ron Angelo P. Alisua from PSME MSE-UPSU. Working in government po ba requires you to always think of new design or innovate, especially sa medical field?
Siguro, yun eh. Yun naman yung mandate ng government. Dapat lahat siguro ng nagtatrabaho sa government ay ganun yung mindset. Kasi tax ng tao yun eh, yung ginagamit dito sa So, binabayaran kami talaga dito para magtrabaho para sa Pilipino. Hindi lang medical field or lahat ng industry na nangangailangan. Dapat matugunan ng government. So, yun yung kailangan mo talagang mag-isip. Advance mag-isip. Parang yun yung requirement. Kailangan mo makaisip ng paraan para masolusyonan yung problema. Hindi pwedeng hindi.
A question from Ezekiel Subere from TUP Taguig. Designing an HVAC system for any building type requires careful planning. As a mechanical engineer, what are the parameters and factors to improve the design of the HVAC system in medical and healthcare world?
Pwedeng pass. Yung HVAC system na ng facility, yun ba yung sa question? So, aminin ko, wala kaming ganong wala pa akong knowledge masyado doon. So, aralin nyo din.
Righam Lucero from UPP asks, Sir, ano po yung plastic na ginamit sa pagprint sa mga fittings at safe po ba siya for humans?
Yung dalawang, kung nakita nyo kanina, may white na fitting doon, tsaka yung may black. Pangalan ko yung isa, ABS yata. Yung isa, yung white na medyo flexible, di ko paalala yung term kasi sila yung may mga partners din kami kasi nga sa 3D printing project, yung AMSEN, na sila yung pumili ng mga materials na yan. Tapos, ang naman dun sa specs, parang safe siya for humans. Tsaka yun nga, kung makikita nyo dun sa design ng ventilator natin, kumbaga wala na talagang interaction yung ventilator dun sa human, sa lungs, kasi palabas na. Dadaan lang sa ventilator after mag-exhale ng patient. So, yun yung design.
Before the next question, we'd like to remind the audience that the evaluation forms are not yet open for tonight. Please wait until the end of the program for the link to the forms. Okay. So for the next question, we have Adenil Kyle Joseph Oronan from Bicol University As seen from your work, we are very much capable of creating locally made medical equipment like the UV testing kit and your ventilator. What hinders the industry in manufacturing these locally made devices?
Hmm. I think, yun nga, dun sa experience pa lang makikita natin to sa, di ba, sa experience ni Dr. Austria, yung walang ventilator yung hospital, tapos manually pinapump yung para doon sa bata. So, parang mapapaisip ka eh, bakit nga ba talaga walang ganun sa Pilipinas na kaya naman talagang gawin ng Pilipino yan eh. So siguro, unang-una, kasi yan, pag R&D, pera din kasi yung kailangan dyan eh. Hindi ka naman magka-come up ng magandang product agad na hindi ka dumaan sa malamang magastos, kailangan mo ng mga resources, saka yung tao din nagagawa. So, ang nakakagawa lang ng mga yun nga, from the government side, since marami tayong resources, yun yung pwedeng mangyari sana na mag-initiate ang government, yun nga yun, from DOH ba yung saka UP, government naman sila. Sa industry kasi, ang tinitingnan nila minsan yung kita din talaga eh, pag ipapasa mo dun sa Kung hindi kikita yung product, kahit gano'ng kaganda yun, gano'ng ka-importante, kung yung business side naman niya ay hindi feasible, hindi magmamaterialize yung mass production. So isa yung sa kino-consider talaga. Unless may need lang talaga na biglaan. Parang ngayon, yung COVID. Hindi kakaiba yan eh. So doon po pasok yung mga innovations. Pero for regular lang na mag-develop ka ng product, mahirap gawin yon na i-expect natin na itatanggapin agad ng market.
A question from Alex Turner from AM. Kung meron part na need ng plastic fittings na gagawin from 3D printing dun sa Austria Vent, anong type ng plastic po yun?
Ay, sorry. Hindi ko alam yung specific na ng plastic. Kasi yung may partner kami from materials engineering naman siya. Siya talaga yung pinakausap namin dun sa Sa side ko, hindi ko pa na-review yun eh. Sorry.
A question from John Ray from Bicol University SU. Except for ventilators po, what other projects did you and your co-workers or your team have already produced? If there is, what kind of project is that?
Mm-hmm. Yung sa Amerial kasi yung sa side namin, yung Amerial halos year 2 pa lang siya ng project. So sa year 1 parang ang activities namin on more on acquisition ng mga equipment na kasi since may bubuuin kaming training facilities. Pero at the same time, nagka-conduct din kami ng consultancy services. So may mga ginagawa kami. Ngayon, simple yung de-oiler ng mushroom. So ano lang siya, parang washing machine. So nilagay namin ng controls na may timer. So yung operator pwede niya nang set kung ilang minutes lang iikot yung machine na yon para hindi na kailangan bantayan pa o orasan ng operator. So yun yung de-oiler. May isa naman, ngayon ongoing, dialysis machine naman. Medyo na kami ngayon sa medical So may balik scientist na nag-propose ng localized, develop a localized dialysis machine. Low cost, yung target, may low cost siya, tapos Filipino made. So yun yung isa sa ginagawa din namin na tutuloy-tuloy pa.
So while we are waiting for the questions, again, we'd like to remind the audience that the evaluation forms are not yet open for tonight. Please wait until the end of the program for the link to the forms. We have another question from Wens from NEU. Mas efficient po ba at economical ang Austria Vent 2 compared sa imported ventilators?
Dalawa yan, efficient at economical. So sa economical siguro may laban. Kasi yun nga, locally developed, wala pa yung importation cost. So yung pwede natin i-reduce talaga. Sa efficiency naman, since undergoing testing pa yung hindi pa talaga siya fully na, ang tawag doon, na kukuha yung performance ng ventilator natin, yung Austria Vent. Hindi ko sure kung ano yung mas efficient sa kanila. Ngayon kasi yung priority talaga yung maging function niya saka yung cost niya. Siguro in the long run, yung efficiency kasi habang ginagamit mo na yun. So, baka mas magastos sa air yung Austria Vent 2 compared sa mga ventilator. Pero sa mga parts naman, hindi ka lagi mag-maintain kasi walang moving parts masyado. Yung ibang meron. So, dun magkakatalo eh. Kasi hindi pa talaga nagagamit ng matagalan yung ventilator, hindi pa namin makikita sa ngayon.
Another question from Shaina Samoy from Tarlac State University. What do you think are the possible problems that may occur while using the Austria Vent 2?
Siguro kasi ngayon yung prototype pa lang kami. So, medyo yung mga wirings niya, yung mga fittings niya, kumbaga hindi siya standardized yung pagkakabit niya. Ang main aim lang kasi namin dun sa prototype, yung functionality. So, siguro pag i-mass produce naman yun, i-consider naman lahat ng naging problems namin. Yung nga, minsan nag-delete, natatanggal yung fittings kasi 3D printed siya. Pero kung i-mass produce siya, tapos gagamitan ng mga standard parts, I think ma-address naman yun yung mga ganong problems na yun. At usual naman sa ventilator, nasisira din naman talaga siya. Pero yun nga, kung at least kayang i-repair locally.
Another question from Miguel Bote from JPSME Xavier University chapter. Sir, would mechanical engineering graduates would took elective subjects focus on other engineering courses, such as biomedical engineering, have an easier time to enter their chosen field career, such as in the medical field, compared to ME graduates who didn't take extra elective subjects?
Siguro, kumbaga may edge niya kayo kasi yung may experience doon sa biomedical engineering compared sa wala. May edge na siya doon sa medical field. Pero, kumbaga, naaral naman lahat eh. Yung yung malaking isang factor doon, yung open ka sa kung hindi mo alam, open ka na aralin yon or yung attitude mo towards certain problem. Pag di mo na alam, so na. So, maraming factors na. Pero yun nga, kung may alam ka na sa simula pala, at least, mauna ka na. May advantage.
Another question from John Ray from Bicol University. When you created the prototype of the ventilator, how many trials did you do, and what are the struggles you experienced?
Prototype? Actually, isang prototype lang yung nagawa namin. Isang prototype. Pero, ang nangyari kasi, kumbaga hindi namin agad nilagay siya doon sa parang case niya. Ginawa namin siya na parang yung mga internal organs niya doon sa loob. Kung nung dinedevelop namin yung system, lang siya nakabukas lang. So yung mga components doon, minsan pinapalitan namin pag hindi talaga siya pwede, nag-leak siya or hindi siya kakasya doon sa isang fitting. So, per component, marami kaming pinapalit-palitan. Pero as a whole, as a prototype na na-develop na, isa lang yung nagawa niya.
Okay. Okay, question from Plaridel Haina from KTP. What developments in your general field or specialization in MEC-Eng are you very much excited about?
Yung automation, part na ng, ano na kasi yun eh. Sa industry kasi, yung automation, robotics, parang ito part na siya na, hindi mo masasabi na ME lang yun eh. So may part din kasi na electronics, controls, ganun din sa 3D printing. May part din doon ng mga materials engineering. So, ngayon wala nang ano eh, yung field ng ME, specialization. Hindi mo na masasabi na ME lang yun eh. So, madami, pero yun yung mga, ano ngayon, nag-boom na ano yun, automation, tsaka
A question from Jan Coley from LPE. We have been working in the same company for years now. Have you at some point felt that your career in engineering has stagnated?
Hindi pa kasi madami kasing projects, parang hindi kami na-stuck sa isang ano lang. Madaming dumarating na project, so exciting pa. Kumbaga, pag may bago, may excite ka eh. So yun lang, ano mo yun as challenge. Every time na may bago, parang magiging next level yun. Lahat ng experience mo dun sa mga previous na projects, pwede mo nang i-apply dun sa. So walang, hindi talaga stagnated.
The thunder. Another question from Nix from TIP Manila asks, what are the requirements for the aspiring ME students na gustong pumasok sa R&D?
Siguro yung ano lang, yung open ka dun sa yung matutunan pa. Willing kang matuto pa. Kasi kaya nga R&D yan eh. So, hindi mo alam kung ano mangyayari. Pero, exciting siya kasi nakikita mo yung progress eh from the start. So, kung i-consider mo yung ano na nagle-learn ka, hindi yung parang kumbaga nagtatrabaho na hirapan ka lang, pinakahirapan ka ng boss mo. Medyo ano yun. Pero kung negative yun sa R&D na kung gusto mo mag-R&D yan. Pero kung i-treat mo yun as challenges, tapos na-excite ka kung may bago. Yun yung siguro yung requirement. Kahit sino naman pwede. Attitude naman doon.
Another question from Luchi Valdez from IBN. Tell us about one of your most successful projects in mechanical engineering.
Siguro yung nag-develop kami ng hybrid train. Kung familiar kayo, nabalita yun ng mga nakaraan. Yung sa PNR. So, locally developed siya from UST, Filipino, parang Filipino yung gumawa. Na, yun nga, kaya naman pala. Kaso, kulang lang sa suporta.
A question from Maria Samson from Paco Catholic School. What advice can you give to people working on engineering projects that address many social issues when their project is not approved because of funding or politics?
Siguro, marami kami experience sa ganyan. Try lang, parang wag sumuko ba? Parang may next project. Siguro yung next, baka ma-approve na yan. So, yung attitude towards na magiging successful yung kaysa sa iisipin mo na, ay, i-disapprove na naman yan pagdating sa sa taas, parang gano'n. So, hanggat kayang may magagawa ka pa, gawin mo lang. Darating din yung chance na yun na ma-approve yan. Parang gano'n.
Jasper Capul from Central Mindanao University asks, does the materials used in your projects are limited when it comes to medical safety?
Yes. Kasi since yung mga components ng ventilator ay yung iba industrial grade lang siya. Pero na-offset siya dun sa design mismo kung saan gagamitin yung ventilator. Kasi hindi, kumbaga yun, ulitin ko, walang direct, kumbaga hindi direct ang may contact yung air na papasok sa lungs ng tao dun sa ventilator. At wala ring chance na bumalik, mag-backflow yung hangin papunta dun sa lungs ng tao. So yun yung naging advantage dun. Kasi hindi kami na-limit na lahat dapat ng components ay medical grade. So kaya nagawa yung prototype.
A follow-up question from Jamaica from URS Rizal. She asks, oxygen supply is expensive. Why let it vent out during exhalation time? Why not control the blender instead or recycle air?
Siguro, pwedeng aralin ulit namin yan. Kasi siyempre, continuous naman yung R&D. Ngayon lang nagkataon talaga na parang ang instruction sa amin is mapagana lang. Huwag na natin sabi yung mga doctors, parang since emergency use siya. Kasi kung mga ganyan, yung magagawa pa tayo, parang magiging conventional ventilator na din tayo na control yung supply. So parang kailangan mo ng medical grade na equipment doon. So kumbaga binalance ng yung depende sa need. So ngayon, expensive yung oxygen, pero kailangan mas mura pa din naman siya or mas kailangan siya kaysa sa mahal yung ventilator tapos same pa rin naman, late na magagawa. Kumbaga hindi na agad magagamit. Ngayon yung kailangan. So yun yung i-consider doon sa design. Siguro sa next na phase ng i-improve na yung efficiency.
Bill from UP Diliman asks, what other innovations do you present businesses or to the new ones do you think our country needs?
Siguro sa ngayon kasi di ba parang yung masyadong work or labor intensive pa yung mga sa manufacturing. Hindi safe, tapos yung tao, kumbaga, more than 8 hours nagtatrabaho para lang makapag-produce ng requirement ng company or ng factory. So may mga technologies kasi, using automation, robotics, na malaki yung magiging tulong niya doon sa businesses na parang magiging competitive siya, may quality, magandang quality ng product. At the same time, safe sa mga employees or sa workers. So yun yung I think yung sa automation side kasi hindi pa tayo umabot dun sa mga automated na production.
Okay, final question from Mikoy Torres from MHS. What is something that you want to tell ME students aspiring to be professionals, like advice or things they should work on or study for the future?
Siguro yung huwag magsawang mag-aral. Isipin nyo, graduate na kayo, tapos mag-aaral pa din naman. Pero yun kasi yung kailangan parang hindi naman kasi lahat talaga matututunan mo agad So yun maging open ka dun sa magiging bagong information or problem na haharapin mo. At the same time, yung attitude mo doon sa mga yung pati yung mga, kasi team naman yan, hindi naman kumbaga sarili mo lang yung mga projects na yan, yung malalaki na in the future. Hindi lang naman ikaw eh. So malaki din yung pinapakita mong attitude towards dun sa mga teammates mo. Lahat naman magagawa yan eh. Ano lang, aral lang talaga.
Okay, that's about it for our Q&A. Timely talk on engineering and its transformational power even in medicine, especially during now the pandemic. Thank you again, Engineer Glen Espeña, for enlightening us about the importance of mechanical engineering in the medical field.
Now, for the awarding of certificates, may we call on Mr. Ram Piamonte, the NMESC 2020 co-head.
It is raining really strong right now, guys. So I hope you're all staying safe. And yeah, so the certificate of appreciation is awarded to Engineer Glen Espeña for his talk on mechanical engineering in the medical field during the National Mechanical Engineering Students Convergence 2020 Gear Up, Restarting Innovation with Mechanical Engineering to Drive a Resilient and Renewed Nation on September 22, 2020.
Sorry, there's a little bunkering. Okay, and that's a wrap for day 2 of the National Mechanical Engineering Students Convergence 2020. We hope you enjoyed and learned a lot from our most esteemed speaker. Stay around for day 3 or drop by in the coming days for more talk. We will also be announcing the winners for the raffle at the beginning of every show, so don't miss out.
Before you leave, we'll be flashing the details for the evaluation form for the raffle and certificates. In the meantime, we will be giving the floor to the NMESC co-head Ram Piemonte and the PSME-UPSU President Ken Villanueva for casual talk on today's event. I am Saidil Yasis.
And I am Jamie Papa. Thank you, good night, and see you again tomorrow. Ken and Ram, take it away.
Yo, Ken, where are you? Ken? Is he not good? Hi, sir.
Hello.
Hi, sir. Also, so for all of you wondering pala, those subjects that sir was talking about, ano ba sinabi mo, sir? Math 54, 55. Yeah. Yeah, math 54 and 55. That is integral calculus and multivariable calculus. We're taking multivariable right now, second years. And sir, what is the other subject? ES? Yung mga ES subjects? Or...
The
ES subjects. Okay, so yeah, ES, actually we had 2 ES subjects naman actually. One, Engr drawing and mechanics on rigid bodies ba? Yeah, rigid bodies. So ayan, so I'm not sure what happened to Ken. I feel like his net is really bad right now and it's raining really hard then, so I'm surprised my internet's still up. So first of all, I'd like to apologize for what happened yesterday with day 1 form. Since the link wasn't restricted, some people had access to it and started editing the questions. Kaya yan, we had to like extend how long it would be open. And yeah, we had a lot of problems with that. Pero rest assured, that is not gonna happen again with the day 2 eval form. So we'll most likely be leaving the day 2 eval form open till I'd say 10 p.m. or maybe a bit longer, at most 10:30. So that's, and I don't really have anything else to say. Ken, you still there or? Yeah, I think Ken's gone. So thank you again, Sir Glenn. I actually learned a lot from your talk there, and I didn't think we'd reach 9:30. Actually, it's almost 9:30. I didn't think it did last that long. That is a lot of questions, actually, sir. So yeah, sir. Any other? Do you have any other words for our young MEs?
Ayun, so pwede kayong pumunta dito sa DOST para yun, i-share namin sa inyo kung ano yung ginagawa namin dito. At baka makumbinsi kayo na mag-work na dito sa DOST. Tulungan nyo kami.
You hear that, guys? So I think Ken came back. Actually, Ken is actually no, I don't think he's. Never mind. So I guess that'll be all. So I'll be flashing the eval scenes now, and so we'll be seeing you all in the next day 3. So day 3 will be with Sir Christian Delia. He'll be giving talk on machine design, and that will be all. So see you guys.
Thank you.